next concept is properties of transpose. Okay, students, next concept, properties of transpose. That means based on transposition, we have some properties we can use directly. So first one is A transpose whole transpose is equal to A. So if you take one example, A is equal to 1, 2, 3, 4. A transpose is equal to 1, 3 write as row, 2, 4 write as second row. So 1, 3, 2, 4. Same you get. What you get? 1, 3, 2, 4. Okay. If you go for again transposition, A transpose whole transpose. A transpose whole transpose means again you have to transpose for this matrix. That means this row write as column, this row write as column. So 1, 3, 2, 4. So what you get? Same matrix you got. So A transpose whole transpose is equal to A. Next, second property. A plus B whole transpose is equal to A transpose plus B transpose. If you take same examples, we can get the answer. Take two different matrices with same order. First you find A plus B. For that one you take the transposition and separately you go for A transpose and for this one B transpose. So then you get A plus B whole transpose is equal to A transpose plus B transpose. Next, A minus B whole transpose is equal to A transpose minus B transpose. And third one, AB whole transpose is equal to AB whole transpose is equal to B transpose into A transpose. Reverse, very very important. Don't write A transpose into B transpose. So matrix multiplication is not commutative. So if you didn't write same order, then you get the wrong answer. So AB whole transpose is equal to B transpose into A transpose. First you write this matrix, next you write this matrix. Next, ABC whole transpose. Similarly, C transpose, B transpose, A transpose. Start from this to this side. Okay. Next, A power n whole transpose is equal to A power n whole transpose. If you want to multiply A power n whole transpose, okay, this gives A transpose whole power n. So what answer you get after raising the power of A up to n? After that, if you transpose, what you get the answer? Same answer you may get. First you transpose and after raise the power up to n. Okay. Next one. For example, if you go for A square whole transpose, if you want to do. Okay. If you want to find out A transpose whole square, we have A square matrix already. We have A square matrix. Okay. If you want to find out A transpose whole square, then directly A square matrix you substitute here and go for the transposition of that matrix. Okay. So A square whole transpose is equal to A transpose whole square. A cube whole transpose is equal to A transpose whole cube. Like that you can write. Next, if A is a symmetric matrix, then Ka is also a symmetric matrix. See one example here. If A is equal to 1, 2, 3, 2, 3, 4, 3, 4, 5. This is a symmetric matrix. Because of A transpose, if you go for 1, 2, 3, 2, 3, 4, 3, 4, 5. So transposition. Again you get the same matrix. Or you have observed principal diagonals are different. These two elements, these two elements, these two elements are same. So it is a symmetric matrix. So if you in the place of K, just if you take some 2, 2A is equal, what you get? 2, 4, 6, 4, 6, 8, 6, 8, 10. So 2A whole transpose if you go for. What is 2A whole transpose? 2, 4, 6 write as first column, 4, 6, 8 write as second column, 6, 8, 10 write as third column. So again this is nothing but 2A. In other words, 2, 6, 10 principal diagonal elements, these two elements are same, these two elements are same, these two elements are same. So we can say 2A also a symmetric matrix. So that means if A is symmetric, then K is also symmetric. Next one. If A is skew symmetric, then K is also skew symmetric. Okay. So take one example for skew symmetric matrix. So all principal diagonal elements are zeros and these two elements are in same magnitude but opposite sign. These two also same magnitude, opposite sign. These two are same magnitude, opposite sign. So automatically it is a skew symmetric matrix. Already we know. Otherwise, if you go for A transposition, so rows as column, columns as rows. If you write this 0, 2, minus 3, write as first column, 2, minus 2, 0, minus 4, write as second column, 3, 4, 0, write as third column. Okay. So if you take minus common from this all entries, so we have 0, 2, minus 3, minus 2, 0, minus 4, 3, 4, 0. So same matrix you get. That is nothing but minus A. So if A transpose is equal to minus A, so it is a skew symmetric matrix. Go for 3A transpose. So go for 3A. If you go for 3A first. 3A means that let us consider K is also a symmetric matrix, skew symmetric matrix we are going to prove. So K means let us consider some 3. So 3A is equal to 0, 6 minus 9, minus 6, 0, minus 12, 9, 12, 0. Okay, go for 3A whole transpose. 3A whole transpose means write this one as columns as rows, rows as columns. Otherwise, you just check it out. All the principal diagonal elements are zeros, and these two are in opposite sign. These two are in opposite sign. These two are in opposite sign, but same magnitude. So automatically, it is a skew symmetric matrix. So what can you say? If A is a skew symmetric, then K is also a skew symmetric matrix. If you observe the matrix directly, you can say skew symmetric. Otherwise, you go for transposition and take minus common, you get the same matrix. This matrix only you may get, that is minus 3A. Okay, then also we can say it is a skew symmetric matrix. Next property. For all A plus A transpose is symmetric. You take any square matrix, no problem. Any square matrix, A plus transposition of that same matrix gives a symmetric. Take one example. If you take A is equal to 1, 2, 3, 4, A transpose is equal to 1, 3, 2. A transpose is equal to what you get? 1, 3. This 1, 3 write as row. This 2, 4 write as column. Sorry, second row. So 1, 3, 2, 4. So transposition over. So add these two matrices. A plus A transpose. 1 plus 1, 2. 2 plus 3, 5. 3 plus 2, 5. 4 plus 4, 8. See here. A plus A transpose whole transpose gives 2, 5 write as column. 5, 8 write as second column. So same matrix you get. So A plus A transpose whole transpose equal A plus A transpose only. So it is a symmetric. And A minus A transpose is also a skew symmetric matrix. A plus A transpose symmetric. A minus A transpose skew symmetric. Let's take one example. A minus A transpose, same. A and A transpose. A minus A transpose, if you observe, 1 minus 1 0, 2 minus 3 minus 1, 3 minus 2 1, 4 minus 4 0. So principal diagonal elements are zeros, and rest of them, these two positions are in opposite sign. These two positions are in opposite sign means it is skew symmetric. So A minus A transpose is always skew symmetric. A plus A transpose is always symmetric. And ninth point, this is very very important. So any square matrix we can express as a sum of the symmetric and skew symmetric matrix. That symmetric matrix, how it form? If you take any matrix is some A, for A symmetric matrix, what is that? A plus A transpose. For B, what is that? A minus A transpose. Okay, if you want to get same matrix A, what we have to do means go for A plus A transpose by 2 plus A minus A transpose by 2. If you take by 2, so if you take A by 2 plus A by 2 plus A transpose by 2 minus A transpose by 2. So plus A transpose by 2 minus A transpose by 2 get cancelled. So now we have A by 2 plus A by 2, that is 2A by 2. 2A by 2 means A only. So A is equal to A. So that means every square matrix A can be expressed as the symmetric sum of the symmetric and skew symmetric matrices. Here symmetric matrix is A plus A transpose by 2. Skew symmetric matrix is A minus A transpose by 2. You can understand. If A is a symmetric matrix, then K is also symmetric. You know A plus A transpose is symmetric, then A plus A transpose by 2. Here 1 by 2 is some K. Okay. If A minus A transpose is skew symmetric, then A minus A K into A minus A transpose also skew symmetric. Here K in the sense 1 by 2. Just remember. Okay, so totally A plus A transpose by 2 is symmetric, A minus A transpose by 2 is skew symmetric. So every square matrix can be expressed as the sum of the symmetric and skew symmetric matrices. See, based on this one question, in a matrix A is equal to minus 5, 0, 2, 1, 2, 3, 4, 5, 6 is expressed as a symmetric and skew symmetric matrix. Find the symmetric. So it can be expressed as a symmetric and skew symmetric. Then find symmetric matrix means for this matrix, what is the symmetric matrix? That is only we have to find out. Okay, after expression, so expressing symmetric and skew symmetric means if we express as the symmetric and skew symmetric matrix, in that expression symmetric matrix is A plus A transpose by 2. That is the important. So required matrix is A plus A transpose by 2. So 1 by 2 you write outside and write A plus A transpose. Here A is minus 502, 1, 2, 3, 4, 5, 6 and A transpose is minus 502, 1, 2, 3, 4, 5, 6. Okay, now we add these two. So 1 by 2 into minus 5 plus minus 5 minus 10, 0 plus 1, 1, 2 plus 4, 6, 1 plus 0, 1, 2 plus 2, 4, 3 plus 5, 8, 4 plus 2, 6, 5 plus 3, 8, 6 plus 6, 12. So 1 by 2 multiply inside, minus 10 by 2, that is minus 5, that is 1 by 2, 6 by 2 is 3, 1 by 2 is 1 by 2, 4 by 2 is 2, 8 by 2 is 4, 6 by 2 is 3, 8 by 2 is 4, 12 by 2 is 6. So this is the matrix we need. So next question, if 130, 10 minus 2 minus 4 minus 4, 4 is equal to P plus Q, where P is symmetric and Q is Q symmetric, then find P minus Q he is asking. Then find P minus Q he is asking. So if they mention if P is symmetric and Q is Q symmetric, then every matrix can be expressed as a symmetric and skew symmetric matrix. In this symmetric, P is A plus A transpose by 2, Q is A minus A transpose by 2. Now he is asking to find out P minus Q. So P minus Q is nothing but A plus A transpose by 2 minus of A minus A transpose by 2. So if you simplify this one, so A by 2 plus A transpose by 2 minus A by 2 minus into minus plus A transpose by 2. So minus A by 2 plus A by 2 cancel. So we have 2A transpose by 2, that is equal to A transpose only. So A transpose is nothing but 130 as first column, 10 minus 2 is second column, minus 4 4 is third column. So 1 1 minus 4, 3 0 minus 4, 0 minus 2, 4. So this is the required answer. In properties, next point, if we 10th point, that is, if A comma B are symmetric matrix, then AB plus BA is also a symmetric matrix. If A comma B are symmetric matrix, then AB plus BA is symmetric matrix. AB minus BA is Q symmetric matrix. See here, proof. A comma B are what they given? Symmetric matrices. That means A transpose is equal to A, B transpose is equal to B. What we have to prove? AB plus BA is symmetric matrix. Then AB plus BA is symmetric matrix means if you want to prove, then you have to take AB plus BA whole transpose, take AB plus BA whole transpose and prove that is equal to AB plus BA. So now consider AB plus BA whole transpose. So already we know A plus B whole transpose is equal to A transpose plus B transpose. That is second property. Okay, so according to second property, this one you can write as AB whole transpose plus BA whole transpose, and we know AB whole transpose is equal to B transpose into A transpose. That is also one of the property, third property. Okay, so according to third property, so AB whole transpose B transpose into A transpose, BA whole transpose is equal to A transpose into B transpose, B transpose is equal to B, A transpose is equal to A, that is BA, A transpose is equal to A, B transpose is equal to B, that is B. In addition, matrices are commutative with respect to addition. So BA plus AB is nothing but AB plus BA. So AB plus BA whole transpose is equal to AB plus BA. So it is a symmetric. Now AB minus BA whole transpose you take to get the skew symmetric. Okay. So AB minus BA whole transpose is equal to AB transpose minus BA whole transpose. That is nothing but B transpose into A transpose minus A transpose into B transpose. B transpose is equal to B, A transpose is equal to A. A transpose is equal to A, B transpose is equal to B. That is nothing but BA minus BB. BA minus AB, but it is not equal to AB minus BA. So it is difference. In difference, we can't write AB as BA, BA as AB. So that's why if you take minus common, then you can write in terms of this one. If you take minus common, so this AB minus AB becomes to plus AB, plus BA becomes to minus BA. So minus of AB minus BA. So AB minus BA whole transpose is equal to minus of AB minus BA. So that means it is in some C transpose is equal to minus C. So what can you say? This is Q symmetric matrix. Next, 11th property. A is symmetric, then A power n is symmetric. If A is symmetric, then A power n is symmetric. Just remember. So always A power n whole transpose is equal to A transpose whole power n. That is equal to A power n. Just remember. If A is symmetric, then A power n is also a symmetric because of A power n whole transpose if you take. So actually A power n whole transpose, that means A power n whole transpose is equal to A transpose whole power n. So A transpose whole power n, what is A? What is A power transpose? Because A is symmetric, A power T is equal to A only. So A power n you get. So A power n whole transpose again A power n. So A power n is a symmetric matrix. Next 12th one. A is skew symmetric, then A power n is symmetric if n is even. Skew symmetric if n is odd. Just remember. If A is skew symmetric, very. If A is symmetric, A power n is always symmetric. N is even or odd, no problem. But if A is skew symmetric, then A power n is symmetric if n is even. That means if A is skew symmetric, A square, A power 4, A power 5, sorry, A power 6, A power 8, A power 10, all these are symmetric matrices. A power 1 is skew symmetric, that is 1 is nothing but odd number. Just you can remember like that. If n is odd, that is skew symmetric. A cube, A power 5, A power 7, all these are skew symmetric matrices. For example, if you go for A power n whole transpose, that is equal to A power t. Actually, this formula is nothing but A transpose whole power n. What is A transpose? That is minus A, because it is skew symmetric. Minus A whole power n. So when you get it is a positive minus A power n, when becomes this minus becomes to positive, and n is even, it becomes to positive. That gives A power n only. So if n is even, you get A power n, that is nothing but symmetric. So if n is odd, you get a minus A power n. Okay. So minus A power n is nothing but, if A power n whole transpose is equal to minus A power n, that is nothing but a skew symmetric matrix. So if n is odd, skew symmetric. If n is even, symmetric.